Hello, welcome to this video. I'm making this video to talk about the questions when it gives us an exponential function. Then the questions ask us to find the inverse function, and then they go on further to ask us to state the domains of that inverse function that we have found. Okay, so this is the title of what we're going to focus on. To find the inverse of an exponential function, and then go on to detect or state down what is the allowable inputs or x value or the domains of the inverse. And at the back of the video, I'm going to provide us with additional information that relates the interesting, some kind of beautiful relation between function and its inverse. So stay tuned and let's go on to tackle the A and B. Let's go. Okay, I've picked one example, okay, and let's read the question. This function is defined for x, which is the elements of real value. And this function is given like this. Find the inverse function for these functions and state its domain. Okay, and then so let's go on. In the first page, I have noted down for the reference for all of us the steps how we can take to assuredly to find the inverse function without any mistakes. Okay, let's go on. Okay, the very first step I put out here, and I still note down, pack the fx, the complicated, the bulky notation f brackets x, a bulky notation into a simple one alphabet letter, which is y. Okay, so this is what we do. Fx, the bulky one, we pack into a y. And then the rest, we just copy from the question. Then we go on to the second step, interchange x and y. The reasons of doing this is when we do the inverse of function, we actually undo the given function, meaning the starting of the function has now become the ending of the inverse, whereas the ending of the function has now become the beginning of the inverse. So that's why the x and y's are actually reversed. Okay, and I also stated down there, after you have interchanged the x and y notation, the y that you have got is actually the inverse of the function that you are looking for. Okay, and then this y eventually will be this notation with the f to the subscripts of -1, which is an inverse. Okay, there you go. So wherever the function you see an y, you now interchange into x, and in a function you see an x, in the inverse you make it into y, and this itself, the y itself, this is the inverse that you are looking for. So let me just highlight that to you. This itself, that y, is the inverse of function. Okay, now let's go on first. After interchange, because we have noted the y, which is the inverse that we are looking for, that is why we want to make it as the subject, because we are looking for it. And then, so here are the step-by-step doing that. So I just swap the subject that we wanted to arrange into on the left-hand side of the equation, and I put an x on the other side. And then now we do the -1 onto both sides, and that results to this. And then here's the 3 of the coefficient of the e. So that's why we are going to divide 3 both sides, and that leads us to this. And then now we have arrived at this stage where your inverse of function, you want to make it as a subject, so that's why we make it into 2y, the index itself, the 2y, and using the conversion formulas from exponential to logarithmic of load. So now we have got to here, then we divide 2 both sides, that leads us to this. And then now this is your inverse of function. Okay, and this you are approaching to the end, and that the final step, we're just going to unpack the y back to its original notation, which is f to the power of -1, which is the notation for inverse. And that's done. You have successfully found the inverse of the exponential. Now the undo of this come in this form. Alright, so this is the inverse. So now let's proceed to the next request from the questions that they ask us to state its domain. Now let's turn the page and move on. Okay, so I've stated down there from the previous slide, we have found the inverse of the function for this exponential. Okay, and then we have also concluded that the inverse of the function is a logarithmic function. Okay, now we want to find its domain, and we want to bring to our remembrance the inside of a logarithmic function must be positive, and that is the idea that we're going to use to find the domain. What is the x that is allowed to put into this function? What is the allowable? Okay, what is the allowable x value to put into this function to ensure it works? And in your calculator, it will not show math error, or we commonly say undefined. So we want to find what is the allowable x, and that is the domain. Then now we use this concept, so the inside, this inside must be positive, so we just put in there as bigger than 0, and we just now, once you arrange that, so now we're just going to simplify to x as the subject. So we multiply 3 both sides, and lead us to this. So then now we just plus 1 both sides, and then it leads us to that. And therefore now the allowable x value to fit into this function must be x which is bigger than 1, and that is the domain of the inverse of the function. X must be bigger than 1. And as promised, I told you that at the end of solving that question, so I'm going to show you additional information. What is the practical aspects, or to get more understanding on what we are doing? Okay, so using a graphical representation. So this is the function. This is the function. Let me just put down there. This is the function. This is the fx. This is the function. And then this is the inverse. And I want us to see its graphical representation and see some of its very interesting facts between them. They have such a beautiful relationship between the function and its inverse. Okay, I have highlighted for us the function. I have put it in blue. So this is the graph that shows the function, and the green one, this line, shows the graph of the inverse. And then I have put in the mirror line for this, and then let's put down there, this is the mirror line, which is y equals to x. And I want you to see what is the interesting things that you see between function and inverse. Yes, you have guessed it right. They are mirror image of each other. So that is the first interesting fact. You notice the relation between function and inverse is they are mirror image of each other. Okay, so this is the mirror line, then they actually reflect each other. Okay, that is interesting facts number one. And second interesting facts I want you to notice, okay, the asymptote. Let's look at the asymptote. The asymptote of the function, we all have read that this is y equals to 1. That is the asymptote for the function. And I want to draw our attention to the asymptote for the inverse. What do you see? X equals 1. What is it? So you notice this y equals to 1. Now, the asymptote for its inverse is x equals to 1. The second interesting fact. Okay? And not finished yet. Let's go on and notice further. Okay, intercept. The intercept for the function, it has to show to us that it is 0, 4. Okay, and then the y-intercept for the function is at 4. And then I want to draw our attention to see an interesting fact. The intercept for the inverse is x-intercept, and it is at 4. Okay, can you see the interesting relation between them? Okay, inverse is at 0, 4. The function intercept at 0, 4, and then the intercept for inverse is 4, 0. So that's another interesting fact. Okay, then the next things I want us to look at is the range and the domain. Okay, so if we look at the range for the function, what is the range for the function? What is the allowable output that will come out from the function? Okay, we know that it's going to, it cannot output y equals to 1. It cannot output that 1 because it cannot touch 1, but it can goes up. Okay, so the range for the function is bigger than 1. So fx or y is bigger than 1. Now let's take a look at the range. This is the range. Okay, this is the range. So I want us to look at this. Okay, the range for the function, range of the function is bigger than 1. But if you notice that for the inverse, the domain is bigger than 1. So you notice this, bigger than 1, and for this one is a range for the function, but for this one is the domain of inverse. Again, you notice the interchange of x and y. Okay, and then let's move on to one more point. Okay, notice that how about the domain for the function? Domain for the function, it can be all real value. Okay, so the blue graph will cover all the way to negative x. It will cover also all the way to the positive x. That is the domain. Domain of function has now become the range of inverse. Let's take a look. If you see that this graph, the range can go all the way to negative y, and then it also can go all the way to positive y, and that gives us all the way real value. Okay, so I have summarized these 4 interesting facts how function and inverse of function interrelate with one another. Let's recap the interesting fact. Okay, the domain, if you look at the domain of the function, the all real value has now appeared, all real value now in the range of the inverse. How about now? The range of domain, the range of function has now become domain of the inverse. Opposite again. Asymptote. Okay, asymptote for function is y equals to 1. But the asymptote for the inverse is x equals to 1. And final point, intercepts. For function, it intercepts at y with 0, 4. Whereas the inverse of function intercepts at x. Again, interchange. And if you look at the coordinate, it has a wonderful and beautiful pattern that is now 0, 4. Okay, so this is the additional information given to all of us to find the beauty of function and inverse of functions. Okay, so that's all for this video. Hopefully this give you some interesting fact and add to some fun of your learning. Alright, so until the next video, bye bye. Thank you for your attention. See you.